we're going to look at today is identifying shapes and interpreting graphs. It's a quick section. We're just going to look at the various shapes of graphs that we can come across in this class. A symmetrical bell-shaped distribution has its highest frequency or peak at the center, with the frequencies steadily decreasing but identically distributed on both sides of center. This is a symmetrical bell-shaped curve. It could be represented in a histogram. A histogram where you have the highest bars in the center and then the bars decreasing in size on either side of center in a symmetrical way is also a symmetric bell-shaped distribution. Okay, so this is representing this is representative of using a bell-shaped curve, but it can also be demonstrated using the rectangles of a histogram. Okay, if we look at a skewed right distribution, it looks like this. Has greater number of relatively low scores and a few extremely high scores. When we talk about scores, we're referring to the numbers on the horizontal axis. Okay, remember that we always label numbers in mathematics on an axis from low on the left to high on the right. Okay, so these numbers go in increasing order from left to right. A greater number of low scores means that these low scores have high frequency. That's why there's this peak over here. The few extremely high scores, these high scores have low frequencies. That's why this is low. On the vertical axis, you consider this high, this low. These high scores have low frequencies on this side. The shape of a skewed distribution has a longer tail on the right, which represents the few extremely high scores. What we have here are high values that have the effect of pulling the tail out to the right. And that's what a skewed right distribution looks like. The tail is being pulled out to the right because there are a few high scores up here that are skewing the data to the right. Just the opposite, skewed to the left, the tail is being pulled out to the left and the data is being skewed to the left. So you have a large number of relatively high scores. So again, imagine high scores on the horizontal axis up here. There's a high frequency for those high scores, and here are the low scores on the horizontal axis with lower frequencies. Okay, what's happening is that those lower frequencies on the left-hand side are skewing the distribution to the left. So this is a skewed left distribution. This is a uniform distribution. It means that every single data value, imagine the data values listed in increasing order on the horizontal axis, have the same exact frequency, the same height. The same exact frequency is going to produce a perfect rectangle, a uniform distribution. So all the classes contain the same number of data values or frequencies. You can imagine what would happen if every rectangle in a histogram had the same exact height. It would mean that every class in that frequency distribution table had the same exact frequency. That would produce a uniform distribution. A U-shaped distribution. Okay, so imagine that you have your data values labeled from low to high. U-shaped distribution is U-shaped. It has the two greatest frequencies, this is a greater frequency and this is the greatest frequency, occurring at each extreme end of the distribution, so one on the left and one on the right, with the lower frequencies, that's right here in the center, occurring in the center. Okay, so U-shaped distribution is pretty obvious. Reverse J-shaped. Reverse J-shaped distribution has the greatest frequency of data values occurring at one end. So we have at the lower scores here have the highest frequencies, and it gradually tails off in the opposite direction. It's definitely different from a skewed distribution. You should not consider this a skewed right distribution. Reverse J-shape, a skewed right tends to look like a bell curve with a tail that's pulled out to the right. The reverse J-shape does not take the appearance of a bell curve. A bimodal distribution has a distribution that has two separate, distinct, and relatively high peaks with the greatest frequencies. So that's here and here. So imagine that you have data values around here that have high frequencies and data values around here that have high frequencies. It usually indicates the distribution represents two different populations. Okay, so imagine that you have male and female heights. Men generally are taller than females in the general population. So if you consider the horizontal axis labeled with heights, maybe 5'6", 5'5" for females would be the highest frequency for females, and then maybe 5'10", 5'11", or 6 foot for males would be the highest frequency of heights for males. Now, if we put them all in the same distribution, male and female, we would produce this bimodal looking distribution that would indicate two peaks for two different high frequencies. Okay, and that concludes the lecture on Chapter 2. At this point, you can complete the web work homework on Chapter